Okay. So I'm gone and out of class today. I should have had a quiz on single displacement reactions. And one thing that I wanted to do to kind of keep the ball rolling today was look at combustion reactions a little bit more. So I've got one of those on the board, and we'll look at a couple of examples of these. When I'm done with this, I went 41 in the book, in your binder, and that has a series of combustion reactions. So out of combustion reactions, you should be able to write the equation, the full equation. You'll be given the reactants, and then you should be able to come up with the products. In this case, we have methane, CH4, and the other reactant. And all of the combustion reactions we're going to look at are hydrocarbons. So this is a hydrocarbon. All it contains is hydrogen and carbon, and that'll be true for all of them. When we're looking at a combustion reaction, if it's complete combustion, and that's important to understand that these are all examples where we have complete combustion. In other words, we have an ideal reaction between the hydrocarbon and the oxygen. So on the reactant side, we always have the hydrocarbon, and the other reactant is always going to be oxygen, O2. Okay, so always be aware of it and remember it's always O2. The other products out of this are always combustion, CO2 and H2O. Okay, so you can automatically write those. Once you have those, it's just a matter of going back and getting everything to balance. So in this case, I need 2 more of these. I've got 4 oxygens, so I'm going to need 2 there, and I believe that's it. 1 carbon, 1 carbon, 4 oxygens, 4 oxygens, 4 hydrogens, 4 hydrogens. So pretty straightforward. Okay. One of the tricks to balancing these, and you'll run into this problem once in a while. Suppose we have C2H. Trying to remember how this works. Let's see, H6, I believe. That's what you're going to wind up with in hydrogens. Again, one of the reactants is always going to be O2. Your products are going to always be CO2 and H2O. Okay. To get this to balance, especially where you have an even number of carbons, there's a trick to this. And we talked about this before. I want to review this. For this, I need 2 carbons. And then always save the oxygen to the end. Okay. Don't do that one until you get everything else worked out. So I need to get my hydrogens to balance. That's going to be a problem. I need 3 of those to get 6 there. Okay. And that'll work. But I'm going to run into a problem when I try to balance the oxygens, because out of the oxygens, I've got 2 carbons, 2 carbons, 6 hydrogens, 6 hydrogens, and I've got 4 plus 3. This is going to be 7 oxygens on that side. Problem here is I only have, it's O2, so it's even, and there's no whole number I can multiply that by to get, I have to multiply by 3.5. in order to get 7. That should give you a clue on this one. This is where you need to double everything, where you need to kind of say, okay, I need the oxygens. Do we need the number? And one way I can do that is by taking that 2, is by saying, okay, I'm going to double that. I'm going to make that 2. I'm going to make this 4, and I'm going to make this 6. Okay, if I do that, then what I have, and let me go ahead and put these down here so we can just make sure that these balance. I've got 4 carbons, 4 carbons. I've got 12 hydrogens, 12 hydrogens, 12 hydrogens. And then if I go back and count my oxygens, I've got 8 plus 6 is going to give me 14. And then I can just put a 7 there. And now that works out. Okay? So good luck on those. We will check the combustion reactions on Tuesday, because we don't have class on Monday. So we'll check these over on Tuesday, okay?